Hi Hayley. I don't have my webcam with me, but hopefully this still works and you can still hear me. Alright, I'm essentially going to go through the questions that you laid out and hopefully that will help. It's just quicker than typing everything out in an email. Alright, for a lot of these trig questions, a key part of the working is a unit circle. So when it's asking for find sine 3 pi on 4, what you'd be expected to do is draw a very rough unit circle and think about where 3 pi on 4 is. Well, if you know here's 0 and all the way around here is pi, 3 pi on 4 is really 3/4 of the way around. So that, or out to there really, that is 3 pi on 4, and what's remaining, this portion in here, is pi on 4. So then what I would expect you to do is to go to a table, unless you're very good at memorizing things, and in a table you'll look here, and now we're looking at sine of this portion here is pi on 4, and sine of pi on 4 is 1 on root 2. There. And because we're in this quadrant out here, sine is still positive, because it's positive in the first and the second. So it's positive 1 on root 2. You may also see that as root 2 on 2. It's the same number. Alright, the general solution. Now this you may not have been shown in year 11, I think Mr. Crawley and I can go through it in week 1. General solution means finding all the possible answers to it. Alright, here you're asked for tan of 2x equals root 3. So I would probably make a substitution here and let a equal 2x, and therefore we have tan a equals root 3. Tan a equals root 3. Now, luckily for us, tan of root 3 is one of our exact ones, and it happens at pi on 3. So we can say that a is equal to pi on 3. However, now's where we put our substitution back. So 2x equals a, 2x equals pi on 3, divide both sides by 2, x is equal to pi on 6. Pi on 3 divided by 2 is pi on 6. Alright, but that's the first solution, it's not the general solution. Let's look at what is happening here in terms of a. In terms of a, what's happening is our first solution happens at pi on 3, just about there. And that means our second solution is out here. So if tan, the other solution is always directly opposite, which will be 4 pi on 3, because we've just added a pi on. So our solutions at this stage really should be a is equal to pi on 3, and there's the second one, 4 pi on 3. And then we're going to have this scenario repeating every pi times. Or really, we can start at pi on 3, and if we add pi, we get there. If we add another pi, we get another answer. If we add another pi, and another pi, and another pi. So really, we could just keep adding answers out here. Or, what we can do is to generalize this, and that's where the general solution comes from, is say we can add on k pi, where k is a member of the integers. So z, for us, or in maths world, z represents whole numbers. This backwards 3, as you described in your email, means as a member of, so is part of. So k is part of the whole numbers, is what that little portion there means. If k is one of the whole numbers, we can add 1k on, 2k on, 3k on, 4k on, etc., and we keep getting more solutions. Now we can make the substitution again, but this time do it fully, not just to the first specific solution, which is that one, but also to the general solution. So when we now divide by 2, we can say that x is equal to pi on 6 plus k pi on 2, where k is a member of the of the integers. Alright, we'll spend more time on that one in week 1, because I didn't realize you hadn't done general solutions in year 11. Alright, next one, period and range. I realize that wasn't actually a question, so I won't spend time on it. But this one here is solve the equation. This backwards 3 is a member of, and this notation is saying x is between 0 and 12, inclusive. So that is, I tried to write it in my handwriting here, but it's terrible. That's just another way of saying x is between 0 and 12. Alright, so to solve this, you want g of x equals to 8. So you have 8 is equal to minus 4 sine pi x on 6 plus 10. Alright, now we solve. So take away 10. Minus 2 equals minus 4 sine pi x on 6. Divide both sides by negative 4. You get positive a half over here equals sine pi x on 6. Alright, so when does sine of what equals pi x? Sorry, sine of what equals a half? You can go back to the table on the previous page. But that there will be equal to pi x on 6 must be equal to pi on 6. Because sine of a half is pi on 6. So, what this is saying is that is our first solution. But remember there's another one. So if we have pi on 6 up here, the other solution for sine occurs over here at 5 pi on 6. So if that's pi on 6 up, we can go 6 around, pi on 6 back, and we're left with 5 pi on 6. So our first two solutions are those two there. However, well, let's just solve for x. So if we solve for x, we divide by pi on 6. Pi on 6 divided by pi on 6 is 1. 5 pi on 6 divided by pi on 6 is 5. So we can see that those are two solutions, 1 and 5 for x. But x, remember, is between 0 and 12. So we sort of get suspicious and feel like there might be another solution here. So as we're going around the circle, what's our next solution? Remember, that's pi on 6, 5 pi on 6. If we went all the way around, like this, is 2 pi, which is the same as 12 pi on 6. 12 pi on 6, to get our next solution, is going to be 13 pi on 6. So our next solution here would be 13 pi on 6, and if we divide it by pi on 6, we would just get 13, which is not a solution. But it was certainly worth checking to see whether the next one would be or wouldn't be. Alright, so our two solutions there are 1 and 5. Alright, here, I guess, is a matter of knowing what properties come from areas of this, or what these are in terms of properties. And I might photocopy you guys part of the Year 11 textbook because it's covered really well in the Year 11 textbook. Alright, the range here is between minus 5 and 5. So if we're thinking, this goes, as a cosine rule, between minus 5 and 5. Now, what that means is that 5 minus 5 is that cos would normally oscillate between minus 1 and 1, but something's multiplied in front of it to increase that minus 1 to 1 bracket to 5 to minus 5, minus 5 to 5. So this a here must be equal to 5. So that gets us our first problem there. Now, period is 4. Period is how often it repeats. So normally cos would look like this. Well, in our case, starting at 5, going down, and it would repeat in every 2 pi times, because we go around the circle every 2 pi. So cosine would repeat every 2 pi, meaning the distance from here to here is normally 2 pi. However, this time it's 4. And here is really the only formula you should be needing to memorize. This period is equal to 2 pi over this here. Now in the Year 11 textbook it's called b, but here it's n. So 2 pi on n. So here, if our period is 4, period equals 2 pi on n. We can solve for n. Multiply up by n, divide down by 4. N equals 2 pi on 4, or n equals pi on 2. And that there is worth remembering to get this one here. So n is equal to pi on 2. Now f of 0 is 2.5. What that means is that if we sub in x equals 0 or t equals 0, then f of t is 2.5. So we have a little bit of algebra to do here, because we've got almost everything, but we just need this last little bit here. So 2.5 is f of t equals 5 cos bracket. Now n for us is pi on 2. So pi on 2 times f of 0 is 0. Then plus this weird curly e thing. It's a Greek, but just treat it like an ordinary variable. Alright, so really this looks like 2.5 equals 5 cos e. Because 2 pi on 2 times 0 is nothing. Divide both sides by 5. A half equals cos e. Alright, now fortunately for us, that's one of the special ones, which should be root 3 on 2. Apologies. So then, lost our little table. Here we go. Cos of a half is pi on 3. So then e, or this Greek, must be equal to pi on 3. And that knocks out our 4 letters. I'll photocopy some Year 11 textbook stuff for you guys to look at as well. Find the general solution. Hopefully, now we've looked at this one up here, you'll have more of an idea what a general solution is. But I'll go through this one anyway, as this one looks a little harder. Alright, what this is saying is that this thing in here, cos of that equals 1. So if we think about the unit circle, well, cos is equal to 1 here. And there has several names. There could be 0. There could also be called 2 pi, 4 pi, 6 pi, etc. So we're going to solve for this first one and then generalize it to add to the others. So what we do is we say, well, 5 bracket x take pi on 6 must equal to 0 plus 2k pi, where k is a member of the integers. So what this portion here is saying is if we add on, say if k is equal to 1, 2 times 1 is 2. If we add on 2 pi, we get a solution. If k was equal to 3, 2 times 3 is 6. If we add on 6 pi, we get another solution, as in we're always getting back to this point. And this part here tells us that k is a member of the the integers. Alright, so then let's look at this equation here. For what values of x will it be 0? Well, x is going to be equal to pi on 6. Alright. And the way we get that is first of all by dividing by 5. So let's divide by 5. Now we have x take pi on 6 equals 0 divided by 5 is 0. But here's the important thing. We must do it to the general case as well. You don't do it after the comma. After the comma is just telling us a bit about k. And then we add pi on 6 to both sides. So x equals pi on 6 plus 2k pi on 5, where k is a member of the integers. Alright, going on down into binomial. Carl takes a car for a service every 6 months. The probability the car will need a minor repair is 0.45. The probability the car will need a major repair is 0.1. The probability the car will need both major and minor repair is 0.04. That would be unfortunate. Alright, what is the probability the car will not require a minor repair, but will require a major repair? Okay. I would approach this, that's actually the first time I read that one, I would approach this using a Venn diagram. So I would be thinking a bit like this. Minor, I'm going to call MI, and major, which for some reason gets a bigger circle, is MA. Alright, now, the probability that it needs a minor repair is 0.45. Alright, so when looking at the probabilities here, we have little regions. I'm going to call them A, B, and C. Now 0.45 is the probability of a minor repair, and lots of people will be tempted to write in 0.45 here. But that's wrong, because the minor repair is the entire circle. So what this is saying is that really A plus B is 0.45. And what it's saying here is that B plus C is 0.1. And the car will be both a minor and major repair. B is 0.04. So that helps us fill in this Venn diagram. This here is 0.04. If that's 0.04, 0.04 off this leaves 0.41 to go there. 0.04 off that leaves 0.06 to go there. So what's the probability the car will not require a minor repair but will need a major repair is describing this number here. So the answer is 0.06. What is the probability the car will not need either a major or minor? Okay, if it won't need either a major or minor, we add these three together and subtract from 1. I'll leave that for you. Given the car requires a minor repair, what is the probability that it will require a major repair? Alright, this is a good question. What this is saying is, given that it requires a minor repair. Given it requires a minor repair means we are absolutely guaranteed to be in here. Alright, so that is our space, and I'm doing terribly at colouring in the lines, but we are in there. What is the probability that it will require a major repair given that we're in there? Okay, so what's the probability of this out of the total? The probability it will require a major repair is 0.04 out of the total in that area, which is 0.45. And if you put that into your calculator, it should give you the answer in terms of probability. Alright, final question, I think. Which of the following could represent probability distributions? Alright, so in probability distributions, two things need to be true. Firstly, the probabilities need to sum. The sum of the probabilities, it must be equal to 1. Secondly, all the probabilities must be greater than or equal to 0. You can't have a negative probability. So in this case here, they sum to 1, they're all positive, tick, it's a probability distribution. These sum to 1, and they're all positive, tick, it's a probability distribution. Here, these do sum to 1, but that's negative, so no, it's not a probability distribution. Alright, I hope that helped. Please email me more questions if it didn't help enough. Alright, thank you very much.